Factor completely. If the polynomial is prime, state this. We have 3x to the fourth minus 48y to the fourth. The first thing you should notice is you have a greatest common factor of 3. So I'll go ahead and factor that out, leaving me with x to the fourth minus 16y to the fourth. Now we have two terms here. When you have two terms, they have to either both be perfect squares or perfect cubes. Since my power is even, then these are both perfect squares. And also because 16 is a perfect square. That means this will factor to be conjugates. So x to the fourth is going to have to be x squared times x squared. And then 16y to the fourth will have to be 4y squared times 4y squared. Now you need to take a look at both of your new factors to see if either one of them factors again. Well, in both cases, your terms are perfect squares. However, when you have a sum of perfect squares, it's prime. So I'll go ahead and rewrite that the way it is. However, since these are perfect squares, and it's a difference then of squares, then it will be factored to be conjugates again. X squared is going to have to be x times x, and 4y squared will be 2y times 2y. Now in this final version here, since my highest power is 1, then they won't factor any further, so they must be prime. So this is the final factorization of 3x to the fourth minus 48y to the fourth.